We went over a lot yesterday, so I don't really have anything to say unless you have questions. I can go over any of the homework problems.
Miss LeGrand, can you hear me?
Oh yeah, I can hear you.
Okay, I can't find a chat box on my screen to type my question.
Okay, we'll just ask it.
Okay.
I didn't know if you could hear me. I didn't know if you had a microphone. Some people don't have microphones.
I was way confused. Okay. So I started on the homework.
Okay.
And I sent you an email, but I'm scared that I'm not on the right track. And because the answers to 5, 6, 7, 8, 9, 10 all depend on the mean, if I get that wrong in question 4.
Oh, are you talking about in the wrap up?
Yes, ma'am.
Oh yeah, I could take a look at that. So let's see. Let me get it. Did you set up the table?
I was able to set up the histogram, and it looks beautiful.
Okay, great.
It's a lot like the one that is, in the actual homework example.
Yay, that's what it's supposed to look like.
Okay.
So to find the mean, did you get an answer for the mean?
Yes. So I've added up the total number of hurricanes for every week, added all of those together, and divided by 16 intervals.
I don't think. No, what you want to do is remember we went back to week 1 and we have group data, right?
Yes, except
so go ahead, sorry.
Well, the part that confused me is when I go back to week 1 and look at group data, I understand that to find the mean that you take the, like if it's how many balls they hit and this many people hit one ball, you take, 1 times that many people, so that, and then you times out the frequency.
Okay, you're missing something. We on the first with the groups, you don't use that whole group. You have to take the midpoint of each of those groups. Do you remember doing that?
I do remember. Okay, so I would take the midpoint and then add all the midpoints and divide by 16.
No, we want to find weeks. So like, okay, let's see. We want to find like between 1 and 2, there's 9. Okay, let's do the first column. So you take the midpoint. What's the midpoint?
4.5.
No, between 1 and 2. See, we're finding the mean of the weeks. We want to know what week number has the average number of hurricanes. So we want to take the midpoint of the weeks. So that's the group data.
1.5?
Frequency, yeah, 1.5. The frequency is just how many times that happens. So when you have group data like this, like suppose it was between 10 and 50, you have to take, you can't take a whole range between 10 and 50. There's 40 numbers. So you have to just reduce it down to one number, and the rule is you take the midpoint of each of those weeks. So then the next column would be the midpoint times the frequency, because that's how many times it happens.
Right. So you get 13.5.
Just for that. Now you're going to do that for each one. And then you're going to add it up. And then you're going to divide by the total number of hurricanes, 851.
Wow, I was way off. I would have screwed the whole homework. Okay, the part that got me on that one, it's because week 1 and 2 doesn't seem like numerical data to me. That seems like information.
Yeah, no, I understand, but it's we want to find the mean week, not the mean number of hurricanes.
Right. And that's where I was lost, because I thought, well, maybe she just worded this question wrong. And I don't know. I don't know how to. Okay. I think I got it now. And I don't think.
No, it's worded. I mean, I understand where you're coming from, because usually we just want to find the mean number of hurricanes, but in this it's the weeks that we're looking at.
Okay.
So again, you're going to take the weeks 1, 2. You're going to find the midpoint of each of those weeks. Then you're going to take the midpoint times the frequency. You're going to add all that up. You're going to get a total, and then you're going to divide it by the total number of hurricanes.
Yeah. That answers my question and helps a lot. I should be able to finish the rest of this assignment then with no trouble.
Okay, and if you can't, just send me answers, and I'll check them along the way.
Okay.
So you're not struggling. I mean, if you look at the rest of the assignment, it's asking for weeks. So, like between what week and what week are, how many percent and so on. So the rest of the problem is weeks. So that's why the mean has to be in terms of weeks.
I gotcha.
And the standard deviation is in terms of weeks. But you can send me your answer, and then I'll check it so that you know you're on the right track.
Yeah,
I
kind of forgot you were going to collaborate this morning, so I actually sent an email just right before you started. So
okay.
You'll see that I totally was not on the right track, but now I've got it. I've written down what you said here, and I can do all this. So
yeah, your histogram looks perfect. Yeah, now just 3. Your 3 is right. Yes, the curve looks, number 2 is correct. And just go back and find the mean. Okay,
yeah.
your mean is off, but I think once you get the mean and you go back and look at your frequency graph, you'll see that you can translate that. Just draw a normal curve. Now, what I'm telling people is on number 6, you have to draw the normal curve by hand. Well, you could draw it and just take a picture of it and put the picture in your assignment is the easiest way to do that. Or you can just draw it and scan your assignment, but a lot of people don't have scanners. So if you just take a picture of it, that's fine. Or, I mean, you can use paint to draw it, or however you want to draw it.
Yeah, I have a scanner, so I'll get that all taken care of.
Okay.
Now, is it important on number 5 when we draw the curve by hand that we have the numbers below it? Like the mean needs to be identified.
Yes.
Okay.
And then you move like +1 over +2 standard deviation. That's what I'm looking for, or that's what the assignment's looking for. Is you put the mean on the normal curve, and then just what is +1, +2, +3 standard deviations, and then you go the other way, -1, -2, -3, and that's all it's looking for.
I gotcha. Okay, well, I'm gonna silent myself here so I can keep working and wait and see if anybody else has questions, and then I'm gonna go back and watch your recording from last night too.
Okay, yeah, we covered a lot last night. We covered percentiles, we covered interquartile ranges, we covered how to use the online calculators. So hopefully that'll be helpful.
Awesome. Thank you so much.
Okay, and you can always email me any questions you have, and I'll be happy to check them.
Sure, I appreciate that.
Okay. All right, I see Laura's here, and Laura, if you have any questions, you could either chat or talk to me. The chat box is like underneath on the right, it's like kind of like a bubble, or you can just talk. I covered a lot last night, so I really don't have anything to say today, but if you have a specific question on the homework, I'll be happy to go over it. I think you joined late, so what we talked about was the wrap up 3. So if you look at the frequency distribution, I know this is messy, it's really hard to write on the screen, but on the wrap up 3, the weeks are in our group data. So what you have to do is you have to take the midpoint of each week and then take that midpoint and multiply by this is the frequency here, 9, and I just did the first row, so that gives you 13.5 because 1.5 happens 9 times. And then you add all those together and divide by the total number of hurricanes, and you're going to get the mean week. Okay, and Giovanna is joining us. So again, hi Giovanna. If you have any questions, please ask. We covered a lot last night, so I don't have anything to go over right now unless you have questions. We covered how to use the online calculators, when to use the normal one, and when to use the inverse one, and we covered percentiles. So what's on the screen now, since you joined late, is wrap up 3. Good morning. And wrap up 3 is group frequency. So you have to take the midpoint of each week in the frequency table and multiply it times the frequency and add all those up and then divide by the total number of hurricanes to get the mean. So this is from week 1. This is how to find the mean with group frequency. This is wrap up 3. But what I was saying, Joanna, is if you have questions, please chat them to me, because last night we covered a lot. We covered pretty much how to use the calculators, the online calculators, normal and inverse normal. We covered percentiles and interquartile ranges. And so what I would like from you is if you have any questions like on the homework or in the knowledge text, I'll be happy to answer those, or anything in general. We also talked about the central limit theorem and why the square root of n was involved in that, and I sent out a video. It's kind of complex mathematics, but just in case you wanted to know where that all came from, Khan Academy explains it very well. So please, hey Tracy, please chat. Like I said, we did most of this last night, but if you have questions that you ran into, please ask. What you see on the screen, since you just joined late, okay, good, Giovanna. If you joined late, this is the wrap up 3. It's group frequency, finding the mean. You have to find the midpoint of each of the groups, multiply that by the frequency, add it up, and then you divide it by the total number of hurricanes to get the mean and the wrap up 3. I guess if you missed it, I can really kind of go over what we went over yesterday. Let me just, I have some examples I can do, unless I'm just waiting for you to chat me something if you have a question. But last night what we did were problems like this. So suppose let's talk about final exam scores. and say they're normally distributed. The mean is 20. Standard deviation is 4. Find the probability that a score is between 15 and 22. Okay, since we have numbers and we're going to the probability, we're going to do the online normal calculator. And I really like this calculator because it gives you the picture of what you're trying to find. Here's our picture. We can draw a normal curve, and the middle is always the mean, which is 20 here. So we want to know what's the area between 15 and 22. The area is the same as the probability, and it's the same as percent. So the area is the same as the probability. So what we're going to do is I'm going to switch to, and let me get a minute to get this online calculator. And I know you can't see it right yet, but I will switch to the calculator. This is the one that you have the link for. Okay, so let me share my screen. Okay, so can everybody see the calculator? Okay, so all we have to do, here's our normal curve. This is the normal distribution calculator. I just type in our mean, and this is so simple. This is all based on, calculus and higher math. That's where they get these numbers. When I was learning stats, you had to look all this stuff up on a table and use a table. So this is so much better that we now have technology that can figure this out for us. So the mean is 20, the standard deviation is 4, and we want the scores between 15 and 22. Now, all of the rest of the stuff you can ignore. It's not going to figure out any of that. I mean, if you want to erase the above and the below and the outside, that's fine. But look at the picture above, the normal curve. You can see that right here it's 15, and right here it's 22, and we're trying to find this area. So this is how probability is related to stats. Probability is the area under the normal distribution curve. So our probability is right here at the bottom. It's 58. It's 0.5858, which is 58%. So 58% of our final exam scores are between 15 and 22. Or the probability that our score is between 15 and 22 is 0.58. Remember, probability always has to be less than 1. It could be equal to 1 if it's certain, but our probability is always less than 1. So when you're answering these problems, you have to be very careful. Are they asking for percentages? In the case, the answer would be 58.6. If they're asking for probability, it's 0.58. Or we would round it up to 0.59 in this case. Okay, so let me go back to the whiteboard. So if you're giving numbers and you want to find the probability, you use the normal calculator. If, suppose, we had the same problem, the standard deviation was 4 and the mean was 20, it's the same problem, and we want to find the 60th percentile. Okay, we have to go back to week 1. Remember what that is. The 60th percentile is the score where 60% of the other scores are below that score. Okay, so basically when you're dealing with percentiles, you're dealing with the normal curve, you're dealing with the place where 60% is below, 60% of the scores are below this number. So we want to find this number right here. We want to find the score. So if you're given the percent or the probability and you want to find the score that's related to it, you have to use the inverse calculator. Okay, so you see the difference between this problem and this is the inverse normal calculator. So before, we just used the normal calculator because we wanted to find the percent or the probability. Now we know the percent and we want to find the score that it's related to. So we use the inverse calculator. So let me go to that one. Okay, it just takes me a minute to get there, but okay, so then we use the inverse normal here. We know the area. The area we want is the same as the percentile, 0.60. 60% of the grades are below. Now, why do we use below? We use below because that's the definition of percentile. Again, percentiles, all the scores that are below that percent. So our mean here was 20, and our standard deviation was 4, and we want below. Now you can look at the picture and see that it's the area below a certain point. Now our point is 21. So if you look on this graph right here where the arrow is, that's 21. So 21 is our score, where 60% of the scores are below 21. So that's when you use the inverse normal calculator, when you know the area or probability or percent and you want to find the number associated with that. So our answer to that problem is 21. %, this number here is 21. 60% of the scores are below 21. That's the 60th. The 60th percentile is the score. So the 60th percentile is 21. All right, so basically that's an example of each type of calculator. I did have a lot of questions. Let me just say this. It asked if the area to the left, and let's do it in this problem since we have this problem up. The area to the left is 0.6. Okay, 60% is 0.6. So what's the area to the right? Well, the whole area is 100%. or 1. Okay? I mean, if the probability that the score is under this curve is certain, okay? So the whole area under the curve is 1 or 100%. So if the area on the left is 60%, what's the area on the right? Well, that's just 1 minus 0.6. So the area on the right is 40%. Those two have to add up to 100%. Okay, so I had a lot of questions on that. Given the area to the left or the right, the other side has to be 1 minus that other area. It's either on the left or the right. It can't be anywhere else. So you're just going to subtract it from 1. Okay, I think, let me check email, see if anybody emailed me a question. But I don't have any other questions. So please chat if you want me to look at any of the learning checks or the knowledge checks. I want to make sure I'm answering your questions. I know you guys are here, but let me know what you're not understanding so I can go over it, please. Last night, like I said, we went over lots of examples, so I think that would be a good session for you to look at. Let's see if I can, I'll just keep doing some examples. Okay, let's say, it doesn't have to be anything specific, but let's say the mean is 50 in this example and the standard deviation is 0.05. This could be any example, test scores, diameters, you know, it can go with anything. Yesterday I did a light bulb example and a push-up example and a fishing example, but you can put this together with anything. And let's say we want the probability that it's between 49.9 and 50.1. So since we want to find the probability, this is going to be the normal calculator. And again, it has to say it's normally distributed. So it will say that in the problem. So let me switch to the normal calculator. Okay, and let's see, we had 50 for the mean, and all we have to do is type it in. 0.05 for our standard deviation, and we want it between probability or the area between 49.9 and 50.1. So 95.45% will be between 49.9 and 50.1. And the reason I really like this calculator is because it shows you the picture of the area. You should always draw a picture for every problem so you can see what they're trying to find. And the mean always goes in the middle. Now, suppose let's go back. Suppose we want the middle, let's say 40%. So we want 40% of our scores to be in the middle. And again, the middle, I don't draw these really good, but it's supposed to be symmetric. The mean is right here in the middle. So 20% is going to be on the left, 20% is going to be on the right. So if we want the middle 40% in this example, again, we're given percent, and we want to find those numbers. We're going to use the inverse normal calculator. So I'm going to go to the calculator, and the area is going to be 40%. Mean is 50. This is the same example as before, and my standard deviation was 0.05. So I want to know what's the numbers where the middle 40%. So I used the between on the calculator. So we see that the middle 40% is between the scores, or whatever this is about, 49.97 and 50.02. If you want the middle percentage, all you have to do is go to the inverse calculator and type in the area that's in the middle and go between, and it'll automatically put it in the middle. If I wanted the 80th percentile, then I would just type in 0.80 for my area and then do below. Because, again, the definition of percentile is everything below that number. So if these were scores, say, the 80th percentile is a score of 50.04, and that means all 80% of the scores are below 50.04. So for percentiles, you always want to use below. And percentiles, again, is the area. And we want to find the numbers, so we use the inverse calculator. Okay, I think pretty much that's the whole, this whole week is based on finding probability or finding the numbers associated with percentiles. Okay, so questions? I mean, I hope this is helping. I don't know what to answer if you don't ask. Is there any other homework problems that you're stuck on? Because I don't mind looking at any of the homework problems. looking through the learning checks now just to see where there might be a question, but again, all of these questions are asking for probability or percentiles, so I think we covered that. And I guess if you were here last night, let me just quickly talk about the central limit theorem again, because I found an answer to your question. The problem is it's not an easy answer. The question was, why do we use the standard deviation over the square root of n? Okay, in statistics, we can prove that the variance, that means how much the data in a sample varies. So the variance of a sample is inversely proportional to the variance of the population. So variance, the definition, and I'm just giving you a brief, this is not approved by any means, I'm just giving you a brief discussion about it. Variance is the standard deviation squared. That's the definition of variance. So the variance, if you take the standard deviation squared of a sample, inversely proportion means that it's going to be the standard deviation squared of the population divided by n. Inversely proportional, right, and this is inversely proportional means not to the variance of the population, but to the to the size of the sample. All right, this should make more sense. Sorry. What that means is if you have a really large sample, then your standard deviation will be small. So if you have thousands and thousands of things in your sample space, then the variance, or how far that data is apart, should be smaller because you have more things in that sample space. So that means if it's inversely proportional, that means when one thing increases, the other thing decreases. So when our sample size increases, our standard deviation decreases. Now, when you look at that and you take the square root of each side, what you get is the standard deviation of the sample space, because when you take the square root of a square, they cancel each other out. Those are opposite operations. So here too, when you take the square root of a fraction, you take the square root of the top, or the numerator, and the square root of the denominator. So the square root of the numerator cancels out that squared. They're opposite operations, and the square root of n stays in the denominator, and that's where it comes from. So we can prove, mathematicians, statisticians can prove that the variance of a sample is inversely proportional to the size of the sample space. And that means, again, that your variance is going to increase as your sample size decreases, or the larger your sample size, the smaller your standard deviation. And that's where this comes in the central limit theorem. So when do you use the central limit theorem, you use it when they give you a sample size. And usually it has to be bigger than 30. So make sure, and the population does not have to be normally distributed. So this is the last section in this week. And I had a lot of questions last night about this, but that is the simplest way I can explain it. So the central limit theorem just says that even if your population is not normally distributed, that means it doesn't have a normal curve shape, the mean of all the samples form a normally distributed set. So it's a very important theorem. It's just that we can only briefly touch on it. So we're not even, this is just the tip of the iceberg. And we won't go any further with this. So when you use the central limit theorem, you're just going to use this new number as your standard deviation in the normal calculator. So you're going to use the mean as whatever is given, and then your standard deviation is going to be the standard deviation over the square root of the sample size. And you're going to use the normal calculator because the means form a normal distribution, and you're going to usually want to try to find the probability that the sample mean is either less than, greater than, or between certain values. That's what that's asking. So that's why we use a normal calculator. It's just this time you have to divide by the square root of n. And you're going to use a calculator to do that and type that in for the standard deviation into that calculator. Okay, so that's the central limit theorem. And again, we're just touching on it. We're not really going to do anything more with it in the future. Well, we do use it, I'm sorry, for hypothesis testing, but it's just mentioned. So there should be no worries about that. Okay, and I did an example of that last night, so hopefully that video should be up. And there were a lot of good questions last night that hopefully I answered. Since I had to switch the Collaborate sessions, if you come across anything else, you can email me, text me, call me. Please, if you have anything else, let me know, and I will certainly get an answer for you. If you ask me specific homework questions, what I try to do is I try to get different examples, so I'm not really answering that one problem. So you can ask me, like, how do you do learning check number 3? That would be fine, but what I'm going to try to do is give you another example and work through it, and then we can go back and forth to see what you don't understand. So I'm not avoiding your question. I'm just trying to get you to think about other ways to think about it. Okay, I hope that helped. Is there anything else I can talk about? Okay, it's not quite 10, but I guess I'm gonna stop right here, unless, again, I'll stay on if you have questions. Please don't hesitate to ask. I think, like I said last night, if you get to watch that one, it'll be really helpful. because I did a lot more examples. Okay, well, I'm going to shut down, and please contact me and I can help you, okay? Take care and have a really good weekend, but I will be able to answer any questions you have. Okay, thanks for coming, Giovanna, and again, don't hesitate to ask me anything, okay? Take care and have a good weekend.